Hello friends. On August 11, 2026, Anthropic announced something that sent developers scrambling. Every Claude model, on every platform, now embeds an invisible watermark in every piece of text it generates. Developers immediately started asking the same question: is Claude hiding secret characters in my output? The answer is no. There are no hidden characters, no invisible Unicode tricks, no steganography. The watermark is a token sampling bias, a statistical fingerprint woven into the way words get chosen, one token at a time. In this video, we are going to break down exactly how that works, why it is so hard to see, and what it actually proves about a piece of text. Let's start from the beginning. To understand the watermark, you first need to understand how a language model actually writes text. It does not write a sentence all at once. It works one small chunk at a time. Each chunk is called a token, which is roughly a word or a short piece of a word. At every step, the model looks at everything it has written so far and produces a list of every possible next token, each with a probability score attached. Think of it like a weighted lottery. Matt might have a 40% chance, Floor a 20% chance, and thousands of other tokens share the rest. The model then randomly picks one ticket from that lottery. That chosen token gets added to the text, and the whole process repeats. This is called autoregressive generation. The watermark lives right inside that lottery draw, and that is exactly what we will look at next. On August 14, 2026, Anthropic confirmed their text watermark as a version of SynthID-Text, a technique Google DeepMind published in the journal Nature in 2024. Here is how it works. Before the model samples the next token, a seed function takes two inputs: a secret cryptographic key held by Anthropic, and the tokens the model just wrote. Those two things together produce a unique score for each candidate token at that step. The scores run a kind of tournament, where certain tokens are favored to advance and others are quietly nudged aside. The model still picks naturally and the text reads normally, but over thousands of steps, a hidden statistical pattern accumulates. No extra characters are added. The model itself does not know this is happening. To understand why the key is the whole trick, let us look at Anthropic's own monopoly analogy next. Alright, here is a helpful analogy for the key logic, and it makes the whole thing click immediately. Imagine you are playing Monopoly, and someone secretly replaces the dice with dice loaded according to the digits of pi. The rolls still look random to every player at the table, but if you already know the dice follow pi, you can predict the expected sequence of rolls and compare it against the actual rolls that came up. A big match is your statistical signal. That is exactly what SynthID-Text does with tokens. Without Anthropic's secret key, the token choices look like ordinary natural text. With the key, a detector can reconstruct the expected tournament scores at every step and run a statistical test against the tokens actually chosen. The bigger the match, the stronger the evidence of a watermark. Now here is the catch. That pattern is surprisingly easy to destroy, and that is what we look at next. Here is the interesting part, and it is the biggest weakness of any statistical watermark. The pattern is tied to the exact sequence of tokens Claude chose, not to the meaning of the text. So what happens when you paste the output into a different language model and ask it to paraphrase? That second model has no watermark key. It reads the meaning, then resamples an entirely new token sequence from scratch. The key-derived tournament scores from the first pass never existed for that model, so the hidden pattern is simply gone. A July 2026 forensic study found a 98.3% watermark removal rate after just one paraphrase pass for SynthID class methods. The study concluded no current method meets the robustness standard required by the EU AI Act when subjected to meaning-preserving paraphrase. That finding extends to other emerging AI transparency regulations as well. Short texts have the same problem from the other direction. Fewer tokens means fewer lottery draws, and the statistical signal never gets strong enough to detect reliably. On to what happens with files rather than plain text. Now, Claude actually uses two completely different mechanisms depending on what it produces. For plain text, everything we have described applies. The statistical watermark is woven into the token choices, it travels invisibly with any copy and paste, and it requires Anthropic's secret key to detect. As of mid-August 2026, no public detection API exists and no third-party tool can read it. For generated image files, such as PNG, JPG, and SVG, Claude takes a different approach entirely. Instead of embedding a statistical pattern inside the content, it attaches C2PA provenance metadata, a cryptographically signed label that records the content's origin. That metadata is publicly verifiable today using existing C2PA-compatible tools. The trade-off is fragility. Resaving the file, converting its format, or taking a screenshot strips that metadata completely. So text watermarks are invisible but unreadable without the key, while C2PA labels are readable today but physically removable. That difference matters a lot for what either one can actually prove, which brings us to our final point. Alright, let us bring it all together. Anthropic is explicit about what a watermark hit actually proves. It proves Claude may have processed that content, not that Claude authored it from scratch. If you paste a human-written essay into Claude to proofread, translate, or summarize it, the output can carry the watermark even though a human wrote the original. And no hit does not prove human authorship either, because paraphrasing or editing can erase the signal entirely. The whole detection system also currently sits behind a closed door. Only Anthropic holds the key. A public API is coming, but as of mid-August 2026 it is not yet available and no third-party tool can perform detection. So here is the key takeaway. The watermark is a real, genuinely invisible statistical fingerprint built into how tokens are sampled, not something added to the text afterward. It is a meaningful step toward AI transparency, but it is probabilistic, not perfect, and it tells you about processing, not authorship. Thanks for watching Webronaq, and we will see you in the next one.